Alright, you guys, well, this is Unit 6, Geometry Review. We are going to start with the odds on page 1. The first section is the algebra section, so I tell my kids to remember MADS, RM. When you're multiplying, you add the exponents. When you're dividing, you subtract them. And when you're raising them to a power, you multiply them. So if you notice, we are multiplying here, and you can only multiply the like terms. So we're going to multiply a cubed times a to the 5th, and I add the exponents, so you're going to get a to the 8th. Then you multiply b squared times b to the 4th, and you add the exponents, so you get b to the 6th. Next, we're going to do number 3. The first thing I notice is that I'm multiplying and I'm raising them to a power. So what you want to do is raise to the power first, then multiply your answer. When you raise it to a power, you multiply, but you can raise the 3 to the 3rd just like normal. So 3 cubed is 27. So you still have the 5a squared b cubed, and that's going to be times 27a to the 3rd, because 1 times 3 is 3. B squared cubed, multiplying those exponents, you get b to the 6th. Now you want to multiply these numbers together, and we treat these whole numbers just like we normally would. 5 times 27 is 135. A squared times a to the 3rd is a to the 5th, because we're adding those exponents. B cubed times b to the 6th is b to the 9th. Next, we are adding. And when you're adding, you just do everything like normal, just combining like terms. So I'm going to start with my x squareds, and I'm going to add them. 2x squared plus a negative 3x squared is negative 1x squared. Then I'm going to do the xy's. So negative 3xy plus 2xy is negative 1xy. Then I notice that this 5xy squared is not the same as 2x squared y, so I can't combine them, and they just stay on the end. I know my answer is ugly, but I have combined all my like terms, so this is the simplified answer. Number 7, we're back to multiplying, but I notice that we're multiplying polynomials. So what we want to do is FOIL this. Because of the plus and the minus there, we're going to do first times the first. 3x times 5x is 15x squared. Then we've got 3x times negative 4 to get negative 12x. 2 times 5x is 10x, and that's a positive 10x. 2 times negative 4 is negative 8. Then we'll combine our like terms to get 15x squared minus 2x minus 8 as the final answer. Number 9 is also another FOIL problem because you're multiplying and you have the plus and the minus in there. So we're going to FOIL just like we did last. 4x times 4x is 16x squared. 4x times a negative 9 is a negative 36x. 9 times 4x is a positive 36x. And 9 times a negative 9 is negative 81. Notice when you combine your like terms here, the negative 36x and the positive 36x, they cancel. And you're just left with 16x squared minus 81. Moving on to number 11. This is a special right triangle. I noticed that I've got a 45-degree angle here. So in my class, what we do is we first start by labeling our pattern. The pattern for a 45, 45, 90 is x, x, x radical 2. And then we start with the side that we are given. So this side is 3. So you start there by setting the pattern equal to the number that you're given. So x equals 3, and then you take that 3 and plug in where there's x's. So this side would be 3, and this side is 3 radical 2. So the x side is 3, and the y side is the 3 radical 2. Instead of moving on to number 13, which is my odd pattern, I'm going to do number 12 since it's a different type of special right triangle. So across from the 30 is the x side, across from the 90 is 2x, and across from the 60 is x radical 3. So we set the leg that we're given equal to our pattern, and then we plug it in elsewhere. So if 14 equals x, then 2x is 28, and x radical 3 is 14 radical 3. So the x side is 28, and this y side is 14 radical 3. Moving on to page 2. We've got another 30, 60, 90 here. So I'm going to label my sides. Across from the 60 is the x radical 3 side. The hypotenuse is 2x, and the short side is x. So you set the pattern equal to the side that you're given, and then you want to solve for x. So if 18 equals x radical 3, then divide by radical 3 to solve for x. And 18 over radical 3 can be simplified to 6 radical 3. If you're in my class, we talked about how we can divide 18 by 3 to get 6, and then tag the radical 3 onto the end. So that side is the x side. So we go over here, and we say he's 6 radical 3, and then we go over here, and we plug in 2 times 6 radical 3, which is 12 radical 3 for the y side. Number 17 says use Pythagorean theorem to solve for the missing side. Leave answers in simplest radical form unless indicated otherwise. So Pythagorean theorem is a squared plus b squared equals c squared, and the c is always across from your hypotenuse. So we're going to say this is a and this is b. 10 squared plus 24 squared equals c squared. 10 squared is 100, plus 24 squared is 576, equals c squared. So you get 100 plus 576 is 676, equals c squared. Then you'll square root both sides. So 676 square rooted, we want to simplify the radical. We want to see what 676 breaks up into. Let's see. We can divide 676 by 2 to get 338. We can divide 338 by 2 to get 169. And I know 169 is a perfect square of 13 and 13. Buddies, buddies. When two groups of buddies get to break out of jail, they multiply. So 13 times 2 is 26. So C equals 26. Perfect. Number 19, we've got C is what we're looking for again. So we're going to plug in a Pythagorean theorem. 6 squared plus 5 squared equals c squared. 6 squared is 36 plus 25 equals c squared. 36 plus 25 is 61. And you want to square root both sides. And 61, I believe, is prime, so this would be your final answer. I don't think it has any factors, but I will double check. Nope, no factors for 61. Alrighty, moving on. 21 says, decide whether the numbers can represent the side lengths of a triangle. If they can, then classify it as right, acute, or obtuse. So what we do is we plug this in to Pythagorean theorem, and if it's equal, then it's right. And if C is less than, then it's acute, and if C is greater than, then it's obtuse. The first thing I want to do for number 21 is see what is the square root of 8. So 8 is 2.8, and so what I know is that these two guys are going to be A and B, and I'm going to set it equal to C squared. So the square root of 8 squared plus 4 squared equals 6 squared. If it equals 6 squared, then it'd be a right triangle, but we're not sure if it equals 6 squared, so we're going to put a box here in order to compare it. The square root of 8 squared is 8. 4 squared is 16. That's something compared to 36. When you add those, you get 24 is something and compared to 36. And what you know is that 24 is less than 36. So that C squared is greater, which makes this obtuse. Moving on to 23, we're going to do that same thing. Take the two smaller ones for your A and your B. So 15 squared plus 36 squared equals, not equals. We're trying to find if it equals 39 squared. 15 squared is 225. Plus 36 squared is 1,296. Something compared to 39 squared. 1521. You want to add those two, 1296 plus 225 to get 1521. 1521 equals 1521, so this guy is right. Moving on to 25, take those two smaller ones, 14 squared plus 48 squared, and see what it compares to 50 squared. 14 squared is 196 plus 48 squared is 2,304, something compared to 50 squared, which is 2,500. Add these guys, 196 plus 2304. To get 2,500 is something compared to 2,500. We know that's equal, so this is a right triangle. Solving for x here on this guy, I know that there's 1, 2, 3, 4 sides to this figure, and so in order to find out what x is, the first thing I want to do is find this angle right here, y. And if this is a four-sided figure, then the interior angle sum is going to add to equal 360. So 101 plus 59 plus 73 plus y equals 360. I found that 360 because n minus 2 times 180 gives me my interior angle sum, and there are four sides here. So 2 times 180 is 360. All quadrilaterals will add to equal 360, so you can just keep that in mind when we get further into quadrilaterals. But you want to add the 101 plus 59 plus 73 to get 233 plus y equals 360. Subtract 233 from both sides to get 127 for y. And then what I know is that if this is 127, then this piece right here is supplementary. So 127 plus x has to equal that straight line of 180. So you're just going to subtract 127 from both sides. And you get 53 degrees. Okay. That's it for pages 1 and 2 of your Unit 6 Geometry Review. Hope that helps, guys. And if you have questions about the evens, please refer to the answer key or come into tutoring.